So today, inshallah, we're going to start with section 2. We will revise rocks from unit 4, section 2 in your book, pages 100 to 102. Your objectives for today: to define rock, list the 3 types of rocks, describe and classify different types of rock, list examples of each type, recognize the 2 types of igneous rock, and also to be able to define and to label a rock cycle, okay? Okay, so let's start by defining rocks. Last time we defined minerals as naturally occurring substance. Now today we will define rocks as a natural solid that is made of 1 or more minerals. So minerals are made of elements, substances, compounds, and rocks are made of minerals, okay? And also rocks can have like organic matter also with it. Now rocks are divided into 3 types, and they are divided or classified according to how they form, okay? We have igneous rocks, sedimentary rocks, and metamorphic rocks. So we have 3 types of rocks, classified based according to how they are formed. Okay. Now, what do I have here in this picture? It's a figure of what? You can answer me. What is it? Look at the figure. It's very clear. Yes, ya Tala?
It's a volcano.
Volcano. And what does it contain?
Lava or magma.
Yes, it contains magma. Who knows what is magma? What is magma? Yes, ya Nada.
It's molten rocks.
Excellent. It's molten rocks. Why they are molten or melted? By what? What melts these rocks? Why they are molten rocks? Yes, Yaleen. How can I have a molten rock, magma? Lynn.
Yes, teacher.
Yeah, Habibti. How or what melted the magma? What causes these rocks to be molten?
Due to the heat and the pressure
Heat and pressure of what?
of the earth, because it's found under Earth's surface.
Thank you. Perfectly. So magma, it's found under the Earth's surface. Do you remember we said that there is the crust, below the crust we have the mantle which contains molten and solid rocks, and we said that they're molten because of the high pressure and temperature. So magma found only below the surface. So it's naturally exists below surface, because under the surface I have a very high pressure and temperature that melts magma. Okay? Okay, good. Now, what's gonna happen if magma reaches the surface? Whether by a volcanic eruption, tectonic plates movement, the magma reach the surface. What's gonna happen? Yes, Haneen? Will it stay as magma, a very hot molten rocks?
Teacher, can you repeat the question, please?
What's gonna happen when magma reaches the surface?
It's gonna be a rock, an igneous rock.
Once the magma is below the surface, it's just magma, it's molten rocks. Now, once the magma reaches the surface, the magma will start to cool down, solidify, forming solid rocks. Now, what if the magma reaches just close to the surface, but not on the surface? Do you think will stay molten or is going to be solid? Yes, Jude.
they're not gonna stay liquid, nor they are gonna become like solid. It's just in between. It will start to be a solid.
Over time, do you think
It will become a rock, igneous rock.
gradual? Bravo. Excellent. Okay. Perfect, girls. So this is the magma, the molten rocks. Once the molten or magma reach surface or just below the surface a little bit, magma starts to cool down to crystallize. We call it crystallization, cooling of magma, okay, to form solids. We call it crystallization. So once the magma is on the surface or just near the surface, magma starts to cool down to crystallize to form the first type of rocks, which is igneous rocks. So igneous rocks are actually formed from magma, from cooling of molten rocks. Now, molten rocks below the surface, we call them magma. On the surface, we call it lava, okay? So igneous rocks can be formed from cooling of magma or lava, in another way, by crystallization. So magma cools, solidifies, forming igneous rocks. So I just told you that this cooling can be happen on the surface or below the surface, just below the surface a little. So according to where this cooling or crystallization is happening, we have two types of igneous rocks. The first type, which we call it intrusive igneous rocks. Intrusive, the first part, in. So it's in the surface, okay? It's within the layers of the earth. It's just below the surface, not exactly on the surface, okay? So intrusive igneous rocks, the magma pushes into the surrounding, but below the earth's surface. Look at the figure here. Magma is not reaching the surface, it's below the surface. It's still covered with other rocks. So once the magma find like weakness point in the earth crust and just push out to the surface or below the surface a little bit, as we have here in intrusive rocks, the pressure and temperature will decrease. So because they're going to decrease, the magma will start to crystallize. And by crystallization, I mean that the atoms found in the magma, they will start to line and to form shapes, regular shapes. And any regular shape, we call it a crystal, okay? That has a specific unit cell. So magma will start to cool down. This cooling is happening so slowly. Jude just told you it's not going to be solid or liquid. It takes time, which is true. For intrusive rocks, cooling is happening so slowly, very slow, that the atoms have all of the time they need to arrange themselves and form crystals, okay? So rock formed from the slow crystallization of molten rocks under the Earth's surface, which is this one, intrusive igneous rock. Yes, Haneen, you have a question?
No, teacher, I forgot to unmute, to lower my hand.
So let's continue again. The first type of igneous rocks, which we call it intrusive. Again, focus. Igneous rocks, they are formed from magma, from molten rocks. Now, for the rocks to form, the magma must leave its high pressure area to the outside, to the surface, or just below the surface. Why is that? Because as long as the magma, it's on a very deep depth, so the magma is under very high pressure and temperature. It's not going to be solid. It's going to stay as a molten rock. So for magma to change into solid, be a rock, the magma leaves its surrounding, leaves the high pressure area to the surface or just near the surface. So if the magma reach just below the surface a little bit, yani near the surface but not on the surface, the magma starts to cool down. This cooling happens very slowly. Since it happens very slowly, the atoms will have their time to arrange themselves and form crystals. If I have slow crystallization under the surface, we call this type of rocks intrusive igneous rocks. Okay, questions now? Any question? Okay, it's just like if I give you time, for example, let's suppose that we are in school, in your class, then I give you 2 minutes to arrange your desks. You're going to arrange them, but it's not going to be the best arrangement. But if I give you 10 or 15 minutes to find out the best arrangement, if you have more time, you're gonna have a better arrangement. So this is the idea here in crystallization. If the atoms are crystallization or cooling down slowly, it means the atoms have the more time to arrange, to form crystals, better regular shapes. But if the atoms are arranging very quickly, so they're not gonna have time to have the best crystals, which is the second type of igneous rocks. We call this type extrusive. It means extruded, means pushed out, okay? So extrusive rocks, the magma erupts onto the surface, which we call it now lava, as you can see in this picture. Because it's on the surface, so the cooling is gonna happen very quickly. So again, there's no time for atoms to form crystals. So usually in this type of igneous rocks, extrusive igneous rocks, we have very small crystals or no crystals at all. An example of that, basalt, okay? Again, extrusive, so extruded on the surface. It means crystallization, it's happening quickly. There is no time to form crystals. So whether we have very small crystals or no crystals at all. And this type, again, happens if I have volcanic eruption like here, or if I have just lava movement. Any questions? Is it clear? Hazim Abu Hijle, miss, turn off your camera if you please. Again, I remind you that you have to keep your camera off. Okay, questions? Right, let's continue. So here, again, another example of the two igneous rocks, intrusive, extrusive. Intrusive, intrusions is under the surface. Extrusive, extruded out to the surface. Here we have examples. Obsidian, for example, here as you notice. It's very soft. There are almost no crystals at all. It has a very dark color. It's black. While diorite on the other side has a lighter color with crystals here. If you look with it under a magnifying glass, you can see crystals. So if I want to do like a quick comparison between igneous rocks, the two types of igneous rocks, intrusive and extrusive. Again, intrusive inside the earth, extrusive outside on the earth surface, intrusive plutonic, and extrusive volcanic. What do I mean by plutonic volcanic? Volcanic eruption, I mean. Plutonic, I mean movement of tectonic plates. Okay? Intrusive, formed from magma, extrusive lava. Intrusive, dark, extrusive, like usually a lighter color, but not necessary. And here, let's look at the cooling. Intrusive, slowly, X, very quickly. In intrusive, we have large grains or crystals. In extrusive, small or no grains or no crystals. Question for you. Do you think igneous rocks contain fossils? Yes or no? What do you think? Yes, ya Muhannad. Sorry, where is your name? Wait, let me choose. Okay, yes, ya Sarah Razan.
No.
Magma, yeah?
Teacher, I can't hear your voice.
Yeah, okay. Thank you, Sarah. So, no, igneous rocks, they don't contain fossils, but why? Here's any ideas, ya Mira Khmoud?
It's because of the high temperature and the pressure on it.
Yes, thank you. We just said that igneous rocks, they are formed from magma, very, very hot magma. So if there is any remains, any organic tissues, any prints left behind, magma is going to melt to dissolve the remains. So rocks, of course, they have no fossils at all. Okay? So is it for igneous rocks? Now I'm going to start with the second type of rocks, which is sedimentary rocks. From the name, you can tell me how it's formed. Sedimentary, yes, Omar. Omar Abu Abid. Yeah,
Teacher,
Omar.
question.
Sedimentary rocks. From their name, can you guess how they form?
They form when the sediments join together and they're put under pressure.
Bravo. Amazing. Thank you. So sedimentary rocks, from their name, so I'm talking about sediments, fragments of rock. Okay? So how these fragments or pieces of other rocks can form sedimentary rocks. Now look at this picture. So here I have fragments which move to the sea. Now in another way, you know that all the rocks on the surface, they're going under erosion, weathering and erosion. So because of weathering and erosion, the rocks is going to be broken into very small pieces or fragments. Now when these sediments join together, cemented together because of the pressure and because of the minerals, the sediments, they're going to form sedimentary rock. Yes, Yaleen, you have a question?
No, I forgot to lower my hand.
It's okay. So sedimentary rocks are formed from, again, sediments that are cemented together. Look again at another picture. Okay. So this is a picture of sedimentary rocks. Now, notice the layers that we have here. It's layer over layer. It's just not like one piece. And that's because sedimentary rocks formed over time. So sediments, they're gathering over time. These sediments, they're going to be under very high pressure, so they will be compact, okay? So they're going to go through compaction. Compaction, which is, I mean, the pressure of the above layers. So sediments, they start together because of deposition. You know, first we have weathering, erosion, deposition. So the rocks, they will be broken down into small pieces, small fragments, then they gather together, and then we start to, we're going to have pressure on the sediments. And then after this pressure, because of the minerals found inside the sediments, we're going to have cementation. Cementation, just like glue. So I'm talking about put the pieces together, press them, squeeze these pieces, and then use glue to keep them together. This is the idea of sedimentary rocks. So first I collect all the pieces, deposition, then I squeeze, I press, I exert a pressure on these pieces. Then I'm going to use glue to keep pieces together. This is happening naturally. Pieces of rocks together, deposition, then pressure is exerted on these pieces by the above layers, so compaction, then the minerals and the water inside the sediments, they're going to work as glue, and this process we call it cementation. Okay? Clear how sedimentary rocks form? Sure, any questions about sedimentary rocks, formation of sedimentary rocks? So when I'm talking about the main processes involved in formation of sedimentary rocks, I'm talking about deposition, compaction, cementation. Okay? Clear? Questions? Okay. Again, we have here another picture. We have here another picture of sedimentary rocks. Again, here we have rocks on the outside, on the surface, so they're going to have erosion and weathering, broken down into small pieces. These pieces, they go together here, deposition, and then going to have a pressure acting on these sediments by the above layers. And over time, minerals and water found inside the minerals, inside the sediments, they will glue these sediments together to form one rock, which we call it cementation. Okay, so sedimentary rocks are formed near the surface. Sometimes at the surface, but it's very rare, usually near the surface. So I'm talking about no heat, sorry, it's not no pressure, there is pressure. So here there is no heat involved in forming sedimentary rocks. Okay, clear? Okay. Now, do you think I'm going to have fossils in sedimentary rocks? Do we have fossils in sedimentary rocks? Yes, no, and why? The same names? Come on, where's the rest of you? You're attending, so you have to participate. Yes, ya Jana.
Because there's no pressure or heat on the rocks, so there will be no fossils in them.
Fossils and sedimentary rocks?
No.
Okay, Jana, let's think of it together. In igneous rocks, we said there is magma, very hot molten rocks that is going to dissolve any remain. Sedimentary rocks, we didn't talk about heat at all. We said the fragments, pieces of rocks, whether it's very large pieces or small pieces, gathered together, and then they're going to have pressure, and then they will be cemented together. So if there is a bone, for example, or a leaf, or any tissue with the sediments, if there is no heat to dissolve it, to melt it, do you think it will stay and form a fossil? There's no heat here. I'm not talking about high heat. I'm not talking about magma, just remains. So what do you think, Jenna?
Oh, yeah, it will have.
Yeah, bravo. So yes, sedimentary rocks, they do have fossils. Actually, all fossils are found in sedimentary rocks. And we just said that in sedimentary rocks, there is no heat. The idea of sedimentary rocks, formation of sedimentary rocks, is just a little bit like the formation of fossils. Layers or sediments covered with other sediments and then compacted and cemented together. But this is the idea of forming fossils. So if I have a print or a tissue, a shell, a bone, any organic matter that is left behind is going to be covered with other sediments, cemented with the rock as a part of the rock. So yes, of course, sedimentary rocks, they do have fossils. And sedimentary rocks, mainly all type of fossils are found in sedimentary rocks. The last type of rocks, which is metamorphic rocks. Now, metamorphic rocks, think of it as an igneous or sedimentary rock. Okay, so it has an origin of igneous or sedimentary rock that put under pressure and temperature. So if I have, for example, an igneous rock, and then this igneous rock covered with other layers and other layers, over time, this igneous rock is covered with a lot of layers. So this igneous rock is under very high pressure of the above layers and a very high temperature or heat. So the igneous rock will start to change and a new rock will form, which we call it metamorphic rock. Same can happen for sedimentary rock. If I have a sedimentary rock that is covered with other sediments, other rocks, or if it's going under very high temperature, the sedimentary rock will change into a metamorphic rock. So metamorphic rocks are actually igneous or sedimentary rocks that change into metamorphic. So I must start with an igneous or sedimentary, then put them under pressure and temperature, they'll change into metamorphic rocks. Okay? So its texture, its hardness, its pattern, its colors, usually everything is going to change because of this pressure and temperature. So for metamorphic rocks, you just need to know that they actually an igneous or sedimentary rock that is under high pressure and temperature change into a metamorphic rock. Clear? Questions? If you have a question, raise your hand. Yeah, Jenna, you have a question?
No, miss, I'm sorry. I forgot my hand raised.
So let's here have a quick comparison between, a quick comparison between rocks. Here I have the source of it. In igneous, we said molten rocks. Magma or lava. In sedimentary, we said it's pieces or sediments from weathering erosion. In metamorphic, so the origin is another rock like sedimentary or igneous rock. Formation processes included in igneous crystallization. In sedimentary, I'm talking about compaction and cementation. Metamorphic, so I'm talking about recrystallization. So I'm talking about changing of the texture. Now, this is a very quick way to actually guess the type of rocks. Reaction with acids, usually in the lab, to find out if it's a sedimentary rock or an igneous or metamorphic. So I can do a very quick test, which is reaction with acid. In the field, we can use lemon even. Just put a little bit lemon on the rock to find out if it's an igneous or sedimentary or metamorphic or sedimentary. Because only sedimentary rocks react with acid. Fossils only found in sedimentary rocks. In igneous, metamorphic, I'm talking about high pressure and temperature, so of course we don't have fossils. Examples in igneous like basalt, granite, diorite, obsidian, many types. In sedimentary, sandstone, limestone, and usually in sedimentary rocks, their name ends with the name stone. Not always, but usually. In metamorphic, marble is a very common example for sedimentary metamorphic rocks. Any questions till now? Yes, Mariam.
Hi, teacher. I just wanted to ask, why do sedimentary rocks they react with acids and they contain fossils?
An original shape, original formation, and an original structure and composition. Okay, so that's why they have higher ability to react with acids. Like if I give you a crystal, any crystals, the atoms are totally arranged in their positions, so they're not going to react. Crystals, they don't react. Okay, not all crystals, but usually. Okay, don't want to say a common rule here. So the last part, which is the rock cycle. The rock cycle shows how the rocks may change from one type to another. I'm going to start from magma and follow me, okay? So magma, by cooling, it forms igneous rocks. The igneous rocks goes to the surface, and on the surface, the igneous rock is going to have weathering erosion, and it will be break into small pieces, sediments. Sediments, they gathered and went under compaction, cementation. I'm going to have sedimentary rocks. Now, what if the sedimentary rock is under pressure and temperature? So in this case, I'm going to have metamorphic rock. If the metamorphic rock is under high temperature and it melts down, so I'm going to have again magma. So it's a cycle actually, from magma to igneous to sedimentary to metamorphic. And it's not necessary to go through all parts of the cycle. For example, igneous rock can go directly under pressure and temperature and change into metamorphic, or metamorphic can be on the surface under weathering and erosion, changes into sedimentary rocks. Okay, so the rock cycle shows that how a rock may change or form, how a sedimentary rock may change into metamorphic, or how an igneous rock may change into a sedimentary or metamorphic. Again here, if I have an igneous rock on the surface, by erosion and weathering, it turns into sediments. Sediments turn into sedimentary rocks, high and pressure. So I'm going to have metamorphic, melting. So I'm going to have magma again and back to the zero. Okay, any questions about rock cycle? No questions? No. So this is our session for today. Thank you for listening. Have a nice day. Inshallah, we have another class on Wednesday for physics. Yes, Sarah.